Here I have a vector application problem dealing with a plane. The plane is traveling 255 miles per hour, 28 degrees west of north, and is affected by a 45 mile per hour air current, 35 degrees south of east. We're looking for the true speed and the direction of the plane. So first of all, I always recommend reading it all the way through first and then start to try to diagram things. Don't just jump right into it. In this situation here, I have two different vectors I'm dealing with. My purple, which is my plane, red, which is my air current. I am cheating a little bit because I've made it so that I have graph paper on here, but you can do it with blank paper. It's just fine with that. But I always think it makes more sense to see it on graph paper. So I'm going to start by drawing my plane vector here. I'm going to try and do it as best to scale as possible, but I'm obviously going to fail at that. So first of all, I know that's 255 and my air current's going to be 45. So the air current's going to be much smaller. I'm going to go 28 degrees west of north. So let's start down here. So west of north. Here is north. I'm drawing, we usually represent north as being up, and we're going west of that, meaning to the left. I'm kind of turning it counterclockwise, and I'm going 28 degrees. So sketching out 28 degrees, maybe like this-ish. So there's my 28 degrees. Then my magnitude here is the speed, which is 255. So there's my first vector that I'm dealing with for the plane. My second vector is the air current. I'm going 35 degrees south of east. So east is this direction here. I'm going south of that, so I'm turning kind of clockwise south of east, and I'm going 35 degrees. So let's call that 35 degrees. Again, I tried to go as much to scale as possible, but it's obviously not perfect. My magnitude here is 45. So really, I'm going to try and figure out the side lengths of each of these triangles, which are going to be my components. So for the purple one, just to kind of give you a visual here, my purple one looks like this, and I have this bottom angle here, meaning for the horizontal component, I'm going to be using sine because sine is opposite over hypotenuse. So for the horizontal, sine of 28 gives me the horizontal component over the magnitude, which is 255. So my component will be 255 times sine of 28. Now it is going to the left. My horizontal component is going to the left, so I know this has to be negative. Now the vertical component, again, I'm looking at my little sketch here, is going up, so I know it's going to be positive. It's also the adjacent side to the angle that I'm looking at. So I'm going to say cosine of 28 equals the vertical component over 255. So I multiply 255 by both sides, and I get my vertical component. Okay, I'll plug that into a calculator in a second. I'm just going to find kind of the equations for my air current first. So horizontal, I'm going to do first here. If I'm looking at this red triangle, it looks like this. And I have the angle here on the left. So for this one, the horizontal component is going to be cosine because it is adjacent to the angle that I'm given. So for this one, cosine of my angle 35 is equal to the adjacent side, or the horizontal component that I'm looking for, over 45, because that's my magnitude. So in this one, I'm going to the right, meaning it's positive, and I'm going to have 45 times cosine of 35. Whereas when I look back here, I'm looking for my vertical component, which is going down, so I know it needs to be negative. And I am going to be using sine because it's opposite of the angle 35 that I'm given. So sine of 35 equals the vertical component over 45. So I got 45 sine of 35. So from here, we have all of our equations that we're dealing with. I'm going to take a second to plug this into a calculator, and then I will come back to you, and we'll deal with the rest of the problem. Okay, so I have now kind of put together the different components here. I've plugged them into a calculator. I rounded these values to the nearest hundredth. In a perfect world, we would keep the exact answers, but for now, I'm going to be fine with just a little bit of rounding, which will give our answer being a little bit off, but I'm okay with that for now. So the next thing that we're going to do is we're going to find the components of the resultant, meaning, in the end, my plane is actually going to be this green line here. And again, this is not necessarily to scale, so we'll double check here, and I'm going to show you why this drawing is actually a little bit wrong because my drawing sucks. So let's look at this, and I'm going to add these values here together. So the horizontal components, 119.72, which is negative 36.86, is going to be negative 82.86. So really, if I drew this correctly, like my arrow should really be on the left side here. So if I were to make some really quick edits, we'll call this, that's my real graph here. So again, be careful with that. Just make sure your drawing is okay, unlike mine. In this case here, 225.15 minus 25.81, and we get about 199.34. Again, rounding may be giving us different values and things like that, but here's the components of my final vector here. So really, if I were to draw that out, I would go, 82 units to the left and almost 200 units up, and I would have a vector that looks like this, which all that hard work to get to our final vector, and now is where we actually find some answers. So once we have that final vector, we're going to go ahead and do two different things. Remember, the question originally asked for the true speed in pink and the direction there in brown. So true speed is the easy one where we're just using Pythagorean theorem, a squared plus b squared equals c squared. So I like to always just use the positive values here, and then I'll deal with the negative values of things if I need to. It really only affects our direction, but in this one here, I'm going to square both of those values and then take the square root of that answer. So I didn't write any of this down, but I'm hoping you're okay with that, to find my magnitude or my speed of about 215.88 miles per hour. So that's my true speed. Now my direction is, I'm looking for this angle here because of the triangle that I drew. To find that, tangent of that angle is equal to the opposite over the adjacent values. So if I did the inverse tangent of that, I get an angle of 67.43 degrees. Now, here's the deal, is that since I'm drawing this angle here and I didn't deal with any negatives or anything like that, I need to use my brain to talk about the actual direction. This is 67.3 degrees north of west. North of west, because west is this dashed line that I created, and I'm going north of that. If I had the opposite side, if I had this angle up here, then that would be west of north. So you really have to decide on how to describe your answer based off of how you drew your triangle and where your angle actually resides. So in this problem here, the true speed is 215.88 miles per hour, and my direction is 67.43 degrees north of west. Or if I, let's say, found the other angle, just for those of you that have gone through and done this, you could also technically have a direction of 22.57 degrees west of north. Both of those describe the same angle. So either one is good.